Welcome to Practical Guide to Research episode 4, and in this episode we'll explain about the confounding factors. It is the hidden distortion in the every study design. In research, the most dangerous mistake is believing what you say, because sometimes the association you measure is not the effect you think you are measuring. That distortion is called confounding. So what is confounding? Confounding occurs when a third variable is associated with both the exposure and the outcome that distorts their true relationship. Okay, then three conditions. First is associated with exposure, second associated with outcome, and third not on the causal pathway. So if all three are satisfied, your estimate is biased. Now let's see how this appears in study designs. Take an example of the cross-sectional study. A cross-sectional study on physical activity and depression, and you find low physical activity, higher depression. Conclusion: physical inactivity causes the depression. But what about chronic illness? Chronic illness reduces activity, chronic illness increases the depression, and chronic illness is not caused by physical activity in this context. So chronic illness is a confounder. Your cross-sectional association is distorted. Without adjustment, your conclusion is incomplete. So take an example of the case control study as well, that is the smoking and the lung cancer. In smoking and lung cancer case control study, there is a cases of the lung cancer patients and controls are healthy individuals. You calculate an odds ratio, but suppose cases are older than average. So age is associated with smoking, age is associated with lung cancer as well. So if not control, your odds ratio is confounded by age. That apparent smoking effect can be exaggerated. Case control studies are especially vulnerable because the groups are artificially constructed. Take an example of the cohort study, like you follow the patients exposed to a drug and you find drug users have lower mortality. So is the drug protective, or are the drug users healthier at baseline? Maybe they are younger, maybe they have fewer comorbidities, or they have better socioeconomic status. These baseline differences confound the associations, and this is called the confounding by indication. So very common in the pharmacoepidemiology. Okay, and have you heard about the database research like NIS? And suppose you analyze the NIS database and you compare hospital A versus hospital B mortality rates, and hospital A shows lower mortality. Conclusion is hospital A provides the better care. But what if the hospital A treats the less severe cases and disease severity confounds the association? Big data does not remove confounding, it sometimes hides it better. And you are familiar with the systematic review. So you pull the observational studies, some adjusted for age and sex, some didn't, some adjusted for comorbidities, some didn't, and now you combine adjusted and unadjusted estimates. Your pooled effect may reflect the confounding difference between the studies. Confounding exists not only within studies but across the studies as well. And final, meta-analyses. Suppose you pull drug versus control mortality outcomes, but studies differ in baseline risks, population age, disease severity. If these modify association and are unevenly distributed, your pooled estimate can be confounded at meta level as well. And this is called residual confounding even after statistical adjustment. So what do you get? Confounding is not the statistical problem. It is the comparison problem. You are comparing groups that are not exchangeable. Randomization fixes this automatically. So randomization fixes this automatically. Observation studies must approximate it. So why beginners fail here? They say I found a significant p-value, but significant does not equal causation. If confounding exists, your estimate is biased even if p-value is less than 0.001. How we control confounding? So we can control confounding by the design stage through randomization, restriction, matching, and in analysis stage, stratification, multivariable regression, and propensity scores. But adjustment only works if you identify the correct confounder. That is why episode 5 will discuss about the DAGs. Thank you for watching. If you want to learn research, just not theoretically but practically, step by step from basics to advanced, keep following Handy Research. This is your practical guide to research and we are building it together. See you in next episode. Thank you.